this episode of the Brady Bunch where everyone gets measles and they're all happy, and so like all the people are like, see, look, you didn't infect the Brady Bunch.
I haven't heard that argument yet. That's a good one.
Yeah, no, Google it. Measles.
So are we 518 list examples? Is this us?
Will you at some point go over the story of how you broke your foot?
It actually wasn't all that entertaining. I mean, earlier in the day, we went ATVing, and that was uneventful. I was like hitting jumps and stuff, like stuff that the guy who was guiding us was not happy about. And then Caruso, and we have video footage of that because Caruso was behind us and he had a GoPro. He kept almost biting it like constantly, but once I kind of figured out how to ride the ruts and stuff, it was pretty good. Got through that unscathed. On the way walking to dinner, there was like a little like a dip in the sidewalk, and it was like just the right light where it looked like a shadow rather than a slope. So I just started to roll my ankle, and actually it would have been better had I rolled my ankle and just fell over. Because it was a little slope, I just slid down the slope with my foot. So my foot rolled halfway, and I just slid down and just landed with all my weight in the side of my foot. So just pal drive the side of my leg with all of my awesomeness. So good. Then I stuck the landing. I didn't fall down. I mean, it was obvious it was broke. You heard the crack through the shoe from like 10 feet away. So then we just walked to dinner. I ate dinner.
No tears, no nothing.
The damage was done.
Well, yeah, there was, but yeah.
So it was,
Right.
no, I mean, it was more anger than. I think at some point you just get ticked off, like, oh, that was stupid.
No,
You
I
know.
cried.
Yeah.
Really? Yeah, I would say it probably wasn't super painful until maybe 3 hours later, once it started getting really swollen, like to the point I had to take a shoe off.
Oh gosh.
Yeah, I laced my shoes real loose the next day.
Yeah.
As I was dragging bags around the airport. So good.
Which
But
part of Mexico did you go to?
Cabo. Yeah, but it makes for a good story. All right, what was the homework? Are we supposed to binary tree of airports?
Of airport quotes.
Okay, well, airport objects sorted by code. That's right? Okay. And I probably gave you the hint, compare to? Okay. So, that didn't help you.
No.
Why? That was like the super hint. Did it help you?
Well, I mean, I knew that already because we had it in the hackathon, so it didn't really help me. Everything else was hard, though. I was taking the hints out of it.
Terrible. Killing me. All right. So let's look up compare to. Compare to returns an int, I believe, right?
Yeah, -1, 0, or 1.
That might be the official implementation in Java. Historically, it will return a value of 0 if they're equivalent, something less than 0 if the calling object is less than the object you passed in. Yeah. But I'm just telling you that because compared to is a historical algorithm for comparing things. It's not just a Java thing.
Okay. So it's like
Yeah. So the official definition of compared to, and we'll add it to the notes just for the sake of.
Java's implementation of the algorithm.
And it's probably pretty common implementation that it returns -1, 0, or 1. But officially, the idea is it. Class is this 518?
Is it just a -1 or 1?
Or 0. 0 if they're equivalent.
Right. It doesn't return like a number, doesn't compare to each value of that string.
Well, so here, I don't even know what you're asking.
Okay.
All right, so we're going to say obj.compared to obj, something like that. We'll call this obj2.
Let's call obj1 dot compared to.
And then obj2.
You got it.
All right, we're happy?
Super happy.
All right, super happy.
Don't even
You don't even know what super happy. You don't know what super happy feels like. Well, morphine, like you get to push the button.
Sure.
Oh man, they would have had to totally take that away from me.
And then he's like, I'm in the 5th floor, and he showed up. He's like, do you know how many floors the hospital has? I was like, how many? He's like, 2. And I was like, oh, all right. So.
Yeah, that would be awesome. So you're saying I need to somehow get hospitalized with this?
You need a morphine pump. Pretty cool. There was no Netflix, so I had my parents put a video store here. This is fun.
So you're saying, because Tabby said I have to wear the boot when I golf on Friday.
Yes.
Now I'm thinking maybe that's not a good idea.
Nah. You could just try to help the doctor out and break it again.
You might be out the rest of the golf.
But with one of those pump things, right?
You might not be there.
So good. Well, I got to get through Copenhagen now.
I was gonna say that. Probably don't let you take it home though, right?
Huh?
They didn't let me take it home. It's just
No, that's why you got to stay in the hospital.
There you go.
I already hit my deductible for the year, so I'm good.
Time for some elective surgery.
I had that discussion with the orthopedic surgeon. 'Cause I need a couple of knees replaced, and
Go for it.
whatever we're gonna do this, we're gonna do it all.
Right now.
I get one of those bionic chairs. You know, we can push the button, you can actually stand you all the way up. Man, it's gonna be awesome once I'm just a full-fledged Terminator. All right, so this guy returns 0 if OBJ1 is equivalent to OBJ2. Returns less than 0 officially. Okay, what you're telling me is the Java implementation returned a -1. Okay, if OBJ1 is less than OBJ2, and I say less than in quotes because you have to kind of determine, like if you use the built-in compare to for strings, we'll look at this in a few minutes, what it does is something called a lexographic comparison. So it's not quite identical to alphabetic, but it's close enough for the assignment, we'll say. Okay, so this returns something smaller than 0 if the guy on the left is less than the guy on the right. Okay? And this guy returns something greater than 0, or a 1, if OBJ1 is greater than OBJ2. That's what compare to does. All right? So first thing we're going to do is we're going to go and explore that tool. Before we just start building solutions, this goes all the way back to the idea you got to understand the problem before you can start writing the solution. Correct? Now, I gave you this hint for this tool. It says, here's a tool you might want to use. Well, before you start using it, you should totally understand how it works, right? You don't go to Home Depot and just buy the crazy looking thing as seen on TV and just come home, plug it in, and start building the shed. Have any of you ever done something like that before? I took out an entire door frame one time with one of those, it's like the Dremel tool things, but the ones that have like the hand.
Oh,
You got the handheld ones. You got the ones that have like the grip stationary thing that I guess have a higher RPMs or something. Yeah, we had to. I was just trying to give a little more space there on the little where the door jamb goes in, where the thing connects, and I just took out the whole door jamb. And then fell onto the floor and kind of ripped up the carpet a bunch. It was awesome. Yep. Anything worth doing is worth doing right. All right, so let's go ahead and explore this compare to guy here for a few minutes. What does our code currently do? Does it at least run?
Yeah. You have a full B-tree implementation.
You what?
Images.
Wasn't up on GitHub though, right?
Correct.
You just kind of watch it.
Yeah, Maddie bugged me about it. You could have asked me for it. I would have put it up there.
I asked for it on Sunday.
But did I?
Yeah, you ignored her. That's why.
Oh, I didn't see it. It wasn't personal. I didn't do it on purpose.
I figured you were busy.
This was
Is it personal? I just don't like it.
just this past Sunday?
Yeah.
Yeah. She
Oh, I just
right
missed it.
before mine.
Yeah.
Yeah.
I figured you were busy.
No, if my intention is always to reply. So if I don't reply to, because sometimes when people were saying a bunch of stuff, I missed something. It was 5 things up. Just send it again or private message me. I'd rather you bug me and get what you need than.
I also thought I was losing my mind because nobody responded, and I was just like, did we write anything last lecture?
I thought I
We
did.
did a lot on through the PowerPoint. But I actually kind of lost it.
All right. So do I actually print out my thing? Do we do like in order and crap?
Yeah,
Yeah,
it's
we
all in
do.
Lockhead.
So here's my visit in order. Visit. Do I do asterisk in there?
Yeah. Are you in the right section of Lockhead?
I don't know.
Let's see. Not lately. Not since
Well, I don't see the asterisks.
we've had a good one.
It's in right there.
Oh, there we go. All right, let's run this puppy again. And then we'll go look at compare to, and then we'll write our B tree in terms of airports. And then you're supposed to have like an interface for kind of traversing it. Okay. Why is that guy? He doesn't think he's running. All right, there we go. Do I not have very many things in my tree?
Should be 5 of them, 6 of them.
It's a main activity.
Yeah, well, this should be my printout. I'm only getting my 5. But what's interesting is this thing doesn't think it's currently running. Let's kill Android
Now you
Studio.
know how we feel.
Let's see if this guy behaves a little bit more now. Is there like 5,000 system updates? No. This guy should stay grayed out like that. Why? Oh, I see. It's still there, but it's still running. Let me just look at this real quick. Let me just visit in order. Build our new string. If we have a left child, set our string equal to our string concatenated with a space, concatenated with that guy visit in order. Then put our self on. Then if we have a right child, do that. That looks right. We'll do something weird in binary tree. Oh, I don't have a complete implementation of add value. Is this like an older version?
No, there was one.
Oh.
I finished it last time.
Okay, well, I'll just write it real quick. Could have been that I rebooted my machine at some point, or it's fine. All right, so if it's the empty, that's why I'm only getting one thing. It's always the root node. So otherwise, what am I going to do? I should have add set in my B tree nodes, right? Yeah, add node. So it must be just like one line that's missing. I just have to call add node. Okay, this dot root dot add. All right, now we should be back in business. Maybe it was even highlighted, and at some point I just hit delete or something. I'd like to access the microphone, but why? All right, now we got stuff. All right, so I have a working binary tree. Okay, so let's look at compare to here for a few minutes, and we'll just do this just following our binary tree stuff just as a sample. We want to understand the how compare to works for strings. So we're going to call this guy string obj1, and we're going to set this guy equal to Milwaukee. We'll say string obj2 equal to, let's just do Atlanta. Pretend like we're dealing with a couple of things. So let's mess with compare to. Now the compare to method already exists for strings, and it does something called lexographic comparison. So it will do. Let's see, I think if I remember correctly, it's backwards. There's some rule for like, doesn't uppercase take precedence over lowercase in real life? If we were alphabetically sorting apple with a capital A and apple with a lowercase a, I think capital A apple technically is supposed to come first. But I think lexicographically it comes second because of where the Unicode values are. But then also I don't think we have like official real life rules for like punctuation, like which is less, 3 question marks or 3 exclamation points. That might not make a whole lot of sense in real life, but lexicographically compare to will give you an answer because it compares the Unicode values for that. We're just going to say that's okay. All right. So I'm going to go ahead and do system.out.println. We'll put a couple of little guys in there, and we're going to concatenate onto this. We'll say obj1.compare to obj2. All right. So we expect, MKE is a larger value than ATL, right? ATL comes first in the alphabet. All right. So since we're saying OBJ1 compared to OBJ2, we should get a, what value should this boil down to? You think a -1 because this guy comes before this guy?
Oh no. Wait.
Should be a 1.
Should be a 1, positive 1. Because this guy comes after this guy. Go back to our
Oh, I see.
notes
I see what
here.
you're saying.
This returns a something greater than 0 or 1 if OBJ1 is greater than OBJ2. All right, so this should give us a 1. We'll go ahead and run this guy real quick. Oh, so that's it right there, right? Isn't this the value that it returned?
Yeah, I guess so.
A little LOL in there. Yeah, so the way I described it is correct. It's not -1, 0, or 1.
Oh yeah, let's try my code, see what it throws out.
That's what
There's
it's
nothing in the tree.
Yeah. Yeah, so what I have here in the slide is accurate. It's a value that is greater than 0 because it's doing a Unicode comparison on the characters. So here I'm going to remove this
So is it
faulty...
returning the actual length of the greater than string? Or
I don't know how it's calculating the value. I think it
seems
probably...
arbitrary.
It's not arbitrary. It's based on math, but it's something with the Unicode values. Might even be like left shifts or something like that. I don't remember. At some point I knew how it calculated it, but it's not just an arbitrary value. All right, so this is giving me a value greater than 0, which says that the first guy comes after the second guy. So OBJ1 is greater than OBJ2. If I flip this around and I say OBJ2 compared to OBJ1, now it should give me something smaller than 0 because OBJ2, which is ATL, comes before MKE. So it should give me something smaller than 0, right?
Why is it giving you 12 in particular?
Well, because I'm using the same characters here. There is a math problem that's solving where it's getting the Unicode value for M, the Unicode value for K, the Unicode value for E, and comparing it to these guys, and it's doing some math with those, which is ultimately giving me a 12. If I change this, if I throw some other things on here, we'll get a value different than 12. Unless it just happens to be at the first, it stops after the first 3. Because that's where it differentiated. Yeah, it did. Let me just switch this to like C or something like that. Yeah, so now we got a -10. So values do change. All right. Now, another thing I'm going to do is I'm going to say string obj3 is equal to new string ATL. Remember we talked about this a couple classes ago, that these, if I use the double equal sign for object2 equal object3, I would get a false. They're not equal to each other because they'll be different memory addresses. But now if I say object2 dot compare to object3, we will get a 0 because they are equivalent to each other. It is comparing they're lexicographically equivalent. Okay, where object2 is ATL, object3 is a different ATL, different memory address version of ATL, and we'll get a value of 0. There's my 0 right there. All right, and then we can see that if I go all lowercase, that it is case sensitive because the Unicode values for ATL are different. For lowercase letters is different than uppercase letters. So there's my -32. All right, that makes sense? Yeah, so what that did is it said that OBJ2 is less than OBJ3 because the value is less. So it says that a capital A should come before an uppercase A. Or an uppercase A comes before a lowercase a, and I want to say that I just have a recollection that the real English rules are actually inverse of that. I don't remember officially, just I remember that lexicographical comparison is one of the comparisons is the inverse of how you would do it if you were following proper grammar rules or something like that. But it doesn't really matter for us. All right, so we understand the compare to tool, what it does. All right, so I can compare two strings to each other. So let's go ahead and let's write our...
Yeah, mine does the same as yours. The numbers are all over the map.
Yeah.
So,
The ASCII.
Question.
Mhm.
When I'm trying to run my app, it says not enough space to create into data partition. Do you know what that means?
Well, it sounds like there's something wrong with the emulator. I would create a new emulator. All right. All right, so we're cool on how compare to works. All right, so now we're going to go ahead and write our binary tree version of airports. Okay, so I'm going to just write a fresh binary tree so we can practice. Did we ever figure out how to create groups here?
oh, no.
No, not yet.
Sorry, now I
It just says folder.
gotta, you just freak out. And take my,
Yeah. This just says Java folder.
Yeah, like comes in like 9:30. I'm just like, I can't do this.
That's right.
What if I create
All
a
of our
Java
Facebook
folder?
streams,
Okay.
I can explain to my boss what happened. Freaked out, no.
Well, I think that's just going to give me...
It's okay. This is really old. I don't want anyone.
I thought it was package, but I don't think it is.
I just saw a folder here. It looks like these are very specific.
Is it under package?
I see Java folder, but it seems like that's just creating another source folder. Let's just, we're just going to test this. We're going to say airport tree. See what that gives us.
Oh, that's sick.
We're all gonna die. All right, it gave me something to look reasonable, so let's go with that. So we'll start throwing stuff in there. All right, so we're gonna have our airport tree, which is gonna be our class, and it's gonna be filled up with, it's gonna be a collection of A trees, something like that, however we wanna call them. All right, and we already have a airport object somewhere, right? Okay. And actually, we can real quickly decide if this is going to probably work. If I'm going to move my move class com blah blah to package. Ooh, I don't really want to make it a different package. Let's just hit refactor and see what happens. All right, so this guy, airport, is now underneath my airport tree. Let's see if things are broken or not broken. Compiler errors. Yeah, I can't find class airport. It's going to want me to import that. Yeah, so it would be from a package.
What do you know?
What do you guys think about that? Yeah. All right, so we're going to call this guy airport tree. We'll put this guy in there. Did it do it? No. I'm just going to dump this and start over. All right, so here's my airport tree package. So we'll create a Java class in here called airport tree. All right, and then we're going to create a new we'll call these guys a tree. Let's just call that good enough. All right, so a airport tree is going to have or an A tree is going to have a payload that is a airport, right? So we're going to have a private airport, and notice it imported list example airport because I'm actually inside of a package called list example, that airport tree. So Java handles its own internal directory structure through, I thought maybe Android Studio would have its own way of handling directories, but it seems like it just uses Java, normal Java packages. So I'll say private airport payload, private A tree left, private
Now, is nodes though?
They don't have to be
Not
nodes.
a tree. They don't have to be nodes?
I mean, you can name it a node, but a binary tree is a tree of trees.
Fair enough.
Yeah, I mean, you call it whatever you want. But these are effectively A trees or effectively our airport tree nodes. All right, so then we'll have our constructor for this guy. So public A tree will take in an airport payload. We'll set this dot payload equal to payload. This dot left equal to null. This dot right equal to null. Okay, and then we need to have the ability to add a tree. So we'll say public my L key not working? All right, public add. This guy will take an A tree A. Return nothing. All right, and what he's going to do is he's going to add A based on the result of compare to with the current payload. Okay, but not the current payload at the airport level, but the current payload at the, so we're going to do it the, call it brute force way, and then we'll override compare to inside of airport. So I'm going to start by just using string compare to. All right, so we know we can't add it locally, so we want to find out, is the current airport payload, should that guy come before the less than or equal to the guy that we're passing in? So we're going to say if this dot payload dot airport code dot compare to a dot this dot payload, that is a airport. Oh, hold on, I'm sorry. A dot payload dot airport code. If this guy is less than or equal to 0, so I'm going to ask my payload, which is an airport, for his airport code, which is a string. I'm going to compare that airport code to the payload of the guy I'm passing in here, his airport code. If it's less than or equal to 0, that means that my payload is greater than the guy that I'm trying to add. So he should go to the left. Correct? Everything to the left of a subtree is less than or equal to it. Everything to the right is greater than it. So if the top level here is greater than the guy I'm trying to add, we put him to the left. All right. Now, a quick object-oriented question here. I am in a class called A tree here, right? All these guys are private variables. I pass in my variable A here. Why can I just say A.payload when payload is private? Why don't I have to write a getter for like get payload? Why am I allowed to just say A.payload?
I have no idea. I use getters in my assignment.
Because we're using a local definition.
This local definition for it would be this dot payload.
It's in the instance of the
Is it
Okay.
private just to the?
What does private mean? Let's define private. What does it? I think you're right. What does private mean? What does it mean for a field to be private? Only visible inside that class. That is inside of a class named A tree. I'm inside of a class called A tree here, aren't I? Now, it just so happens I'm talking about this particular instance of A tree's payload, and I'm also talking about another instance of A tree's payload. But because I am inside of a class called A tree, I have access to those private members. Does that make sense? I didn't need to create a getter. Making this guy private says I can access this variable, any of these private variables, I can access them as long as I am inside the class called A tree. That makes some sense? Now, is that something you ever have to really know? You can just write getters and setters and move on with life, but sometimes you'll see code like this and you're like, well, why does that work? And it's easy to say, well, it works, it just works, so I'm not gonna worry about it, okay? But it's explainable is what I'm getting at, okay? So right here, we're asking the question, if the current airport code, this guy's airport code, is greater than, well, if it's less than the airport code of the guy we're trying to add, actually, hold on, the way I've written this is, if this gives me a number that's less than or equal to 0, that means that this guy is smaller than this guy, which means he should go to the right. Correct? So it's the calling, this was, in our example, this is OBJ1, this is OBJ2. So if OBJ1 compared to OBJ2 gives me a value less than or equal to 0, that means that OBJ1 is smaller than OBJ2. So in this case, since this is OBJ2, we need to add him to the right of this guy because he is a larger value, and all the larger values go to the right. So we will say if this dot right is equal to null, this dot right is equal to A. Else this dot right dot add A. Else it must need to go to the left. So if this dot left is equal to null, this dot left is equal to A, else this dot left dot add A. All right, does that make sense? So that is our, well, I just need to finish it up inside of airport tree. We pretty much have our entire binary tree now of airports. So in our airport tree, we're going to have a private A tree called root, public airport tree, takes no parameters. We'll say this dot root is equal to null. We might decide we care about how many things are in here, so I'm not going to care about how many things are in there. Just keep it simple. Then we'll have public void add, and this guy will take in an airport payload. It is the L key. Something's wrong with mine. It doesn't let you just hold down keys? All right. I'll say this dot if this dot root is equal to null. Oh my gosh, are you kidding me? This dot root is equal to, actually I need to make my A tree anyways. A tree A is equal to new A tree, and I pass this guy payload. Set that equal to A. Else this dot root dot add A. All right, so that's my binary tree. Okay, so now, just so we can test to make sure our binary tree is working correctly, well, here I'll ask you, what's the best way to test to see if this tree is working correctly? I now have what I believe is a working version of a binary tree of airports. How can I test this guy? Okay, where do I get my data?
Oh, yeah, so just go ahead and make, go ahead and throw some in on your own, create method in main, and just try to populate a tree.
Okay. But don't we, I mean, what is an airport? What's an airport have in it? We give it all this crap?
So I use generics. Test my tree out with integers and then
No, but we already have a whole bunch of airports, don't we? Don't we read in our airports from our,
they're in the airport cache, I suppose.
yeah. So can't we just, don't we create a bunch of airports inside of, what's that screen called? Airport list activity? Yeah, look at this. Getting a whole awesome airport here. Yeah, so we'll just build our airport tree in here and print it out. Prove that it's all legit, right? So we need to add a visit in order. In order is the one that gives us the correct order, right?
In order sorts it.
Yep. So we'll go to our airport tree, and we'll go ahead and say public void visit in order. Okay, and we'll just do a system.out.println. Yeah, this is gonna bug me. You get one of those air things. All right.
So it used to be able to hold it down, and now you can't?
Well, no, it used to work all the time. Now it's not working all the time. I keep missing L's pretty consistently. I usually don't miss keys. I mean, if I miss keys, I'm off a key. Like I don't hit a key and then nothing happens. All right, so system.out.println, we'll put a couple of asterisks there. We'll say airports, something like that. And then we'll say this dot root dot, oh, I need to go write visit in order for that guy, so I'll just do that real quick. That is my A tree. We'll have a public string visit in order. All right, and we'll say string answer. We'll start off as the empty string. I'm thinking we'll just go ahead and just get to just the airport codes of these guys for visiting, just so we have like MKE, comma, blah, 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 something like that. All right, so visit in order says visit ourself, followed by our left child, followed by our right child. Or that's pre-order, right? In order says visit my left child, then visit myself, then visit my right child. So we're going to go ahead and say if this dot left is not equal to null. If I have a left child, answer is equal to, or so we'll answer plus equals to this dot. Oh my gosh, are you kidding me? All right, so this dot left dot visit in order. Then we'll visit our self, and that'll say answer plus equals. I'll just I'll just put a space in, it's fine. And then we'll say this dot payload dot airport code. Then if this dot write is not equal to null, answer plus equals this dot write dot visit in order. And at the end, return answer. All right, so that's visit in order at the A tree level. Then we go back up to the airport tree level, and we'll just concatenate onto this dot root dot visit in order. Don't call this unless you actually have don't call this on the empty tree, it'll crash. Okay, so now what we'll do is we will go into, where was it? Airport list activity. And this is where we're getting all our airports. So before this guy, we'll go ahead and we'll create a, what I call it, airport tree. Airport tree. A tree is equal to new airport tree. And then each time through, after I get something, I'll say a tree dot add temp. And then down here at the bottom, we'll go ahead and do a system. Actually, we don't need to do, we're printing it. Don't I print it out inside of airport tree? I do. So I'll just say a tree dot visit in order. And we should get a whole bunch of airport codes that look lexigraphically sorted. Whatever that ultimately means. And I think didn't I put four little dudes before it? Yes, I could sort on 4. Filter it better. Okay, so we're gonna go to our airport list. Looks legit. All right, so there's our binary tree of airports. Is that it for the homework? What to do? Oh, okay. Do that. Oh, that was probably fun, the interface, wasn't it? Child?
Child, yeah.
Like human offspring.
I have a question. Do you want us to sort it then before we throw it into the tree? Or into the... No, you didn't want it. Like, did you want the user interface to do it in order? No, you just said tree traversing. So
Yeah. We're just proving our tree worked here. We just happen to know that visit in order gives us it sorted, and
Sure.
things look pretty legit, so our writing must have worked. All that crap. Okay, so again, our binary tree thing's pretty easy, no big deal. All right, so now let's go ahead and build our interface. So we'll give ourselves like a button off that main page. And
Explore the tree button. That's what I call mine.
and what did I do here? I said, I think I'll do it off this next screen. That way we have that.
Oh, wait, I wrote a whole new program. I just thought.
Oh, well, whatever, doesn't matter. What was I thinking? I was thinking something.
User interface.
Did I give you guys a hint about? You shouldn't have needed the hint because we've done it before, but serialized data.
Right.
I gave you that hint, right?
It was not right away,
That'd be close to right away.
I I singletoned my data. So,
Coward, man. You're going to be so angry when you see how I do this.
serializable. I was like, yeah, it's time to singleton this.
Passing it through intense.
Yeah.
I thought you like struggled with it like one time. And you're like, oh, it's really easy. So you like extended a class with the serializable interface, and it never worked. And you're just like singletons, guys. I'm like, okay.
Yeah, it depends what you're doing. In this case, the passing it. Well, here, I'll show you.
That's
Oh,
the first thing I tried doing, and then I threw everything in for.
oh, you didn't get it to work.
I didn't get it to work.
Oh, oh I didn't get it.
I didn't even try them. So at least you
I
didn't
just
try.
spun my laptop down the stairs and let a bunch of keys hit. Did it work? No, but I mean, it's what.
So I tried it.
All right, so what we'll do is I'll show you the serializable version of this first. Then we'll assume you couldn't get the
I
serializable.
didn't get it to work because I knew I wasn't doing it right. I was passing the airport, the whole airport object. Is that what we're supposed to do?
I think you'd have to.
No, you would pass a tree.
Yeah, I was doing each airport.
Because isn't our screen going to show the current state of a tree? It's going to say, here's what the payload of this tree is. And here's the left and the right child. Click the button to go.
Yeah. So sorry, you mean node? I was passing the nodes.
That's fine.
Or whatever you want to
You-
call it.
yeah.
Passing X.
Yeah.
Which is a single parent and two children, but not like the complete.
Well, but hold on. But this is an important distinction. You can call it a node if you want. But a binary tree is a collection of binary trees.
Fair enough. Okay.
Yeah. You see what I'm saying?
So it's
So
a
it's-
superset of the.
Yeah. So you could have a binary tree that has two children, and those children are each binary trees.
Sure. So if we go to set.
This guy has two children. Those children are each binary trees. They're not nodes. When we think about linked lists, we have a linked list that's a bunch of nodes linked together. Binary trees are collections of binary trees.
I understand what you're saying.
All right, so
I'm
Let's-
just gonna call it a node, but it makes sense what you're saying.
let's build ourselves a little interface here. All right. Let me give myself a button first. What screen is this guy? It's my.
List activity.
So I'm gonna put a little button up here next to filter that says explore or something.
Explore the tree.
Is that under layouts? Activity airport list? Right. Dora's the Explorer, right?
From Mexico. Perfect.
Do you know Dora the Explorer? You don't know Dora the Explorer?
Oh dear God.
You should just watch the this video.
This is Dora the Explorer. It's like a kid's cartoon where you learn Spanish and English at the same time. It's a really, really funny knockoff from like Saturday Night Live from years ago or something like that, where she's speaking in all sorts of languages other than Spanish, using clicks and stuff. All right, hold on.
Okay, we gotta watch that.
Okay, so only Lippmann can incorporate that into a variable name in your code.
They call them method Maraca.
Yeah.
That's not a bad idea. All right, so I'm gonna we'll have the maraca. All right, so we're gonna have this button take us to our special interface page, dealy flippy thingamajig. Okay, so I gotta make. Did I make that already? No. So we'll put this into our. I'll say I'm gonna have a new empty activity. I'm putting it inside my airport tree thing. So we're gonna call this guy airport tree view activity. Good enough? Oh, is it not going to like me having it in outside of
You have to build it outside of it and pull it
no, it's because of the import stuff here. I'll leave all my activities outside. Life will be easier that way. All right, so here's my airport tree view. I'm going to go ahead and convert this view to a linear layout with, here's my orientation vertical. All right, so we're going to have like something at the top for payload. Maybe we'll just show the airport code or something, or did I have you do more than that? Say airport code and city state or something?
Airport code and city.
Airport code and city?
Oh, yeah.
MK in Milwaukee.
I was gonna say airport code because that's what I did.
Well, it doesn't matter. It doesn't matter. Okay, so I'll go ahead and put a text view in here. And this guy is going to be our airport code TV. Make that bigger. And then we'll, my font. Good enough. And we'll go to gravity. And center it. Okay. Then I'll go ahead and put a horizontal linear layout in here. And I'll throw a couple of buttons in there. All right, and this is going to be left button. Left, and this is going to be right button. Right, like that. I'll just put some sample text in here like MKE. We'll just do airport codes for right now. We can always add more crap. Okay, so that's what our screen's going to look like. Let's just have one of these show up real quick when we click our button on our, which was our airport list activity, this guy. All right, so we'll go ahead and say public void on Maraca click UV. All right, and this guy we're going to create an intent. Passing it to this context and passing it, what's the name of our airport tree view? View activity.class. That dude. Okay. Then we'll just say this dot start activity for right now. Passing it I. And that should start it. Go hook the button up, make sure we can get there. This is airport list. Here's Maraca. Here's on click. Here's on Maraca click. All right. So let's just make sure we can get to an empty starter screen for that. All right, so go to airport lists, blah, blah, blah. We'll go ahead and go to Maraca, takes us here. All right, so that's kind of where we're at for this guy. All right, so let's, I think building out this interface is gonna probably take, well, it'll probably take 20 minutes or so to explain how the serialized thing, and we're gonna do it 3 different ways. So why don't we take 5 minutes? We'll take 7 minutes. Let's take a 7-minute break. We'll come back and we'll have part 2B, build this interface.
Did you click over to A tree?
No. This guy?
Yep.
We're going to be changing this soon.
Oh, we are.
Not by much. We're going to be making most stuff public because we're going to be turning it into serializable.